Hello everyone, I'm Sumit Agrawal and I'm a software developer here at Archie.ai. And today I will be giving a workshop on what is a generative model and a deep insight about how we can create a basic generative model. Before I talk about that, I want to give a brief recap about what our team has done till now. We have given six workshops on various topics on various artificial intelligence. Along with that, we have given two workshops on how to create your own bot in 10 minutes and how to create your own Google Assistant app in a few minutes. You can check out all that workshops on our channel of on YouTube. I will be sharing that link below this video, and yeah, you're free to check out that. So coming back to the generative model, what exactly is generative model? So generative model is a term which was first coined by Ian Goodfellow in 2014. Generative model basically is a special type of neural networks that uses a computation feature to train itself. So generative model has two components. One is the generator and another one is the discriminator. Both are neural network, and they try to compete with each other, and in the process they get better and better. So for example, you can think of generator as a forger who is trying to generate a fake money bill, and a discriminator as a policeman who is trying to identify whether the money bill is fake or real. So at the beginning, the generator and the discriminator both are at a knife, and they don't know the details about how to generate money bill and how to identify whether a bill is fake or real. So the generator creates an image of a bill, and discriminator takes that image as an input and tries to find mistakes in that image. And the discriminator then gives a feedback to the generator about what mistakes it found. And generator the generator tries to update its weights and rectify that mistakes. And this to and fro between generator and discriminator makes both the models stronger and stronger. At the end, the generator is able to generate money bills which can fool human eyes. At the same time, the discriminator will be able to find minute mistakes in the money bill, which is not possible by a human eye to detect. So this was the basic introduction about generative model and the structure of generative model. So in the past couple of years after it was introduced, people have worked on generative models and came up with various applications, such as the Google Deep Dream, where they were able to, the Google neural network was able to take in images, and with the help of their advanced neural network, they were able to generate sacrific images. Another application is the Facebook AI team. They came up with a model called the neural faces, where the model was able to generate realistic yet fake human faces. There are many other applications of generative models, and I have written a blog on this applications in Medium, and you can check out that blog. I will share the link below this video. So in today's tutorial, I will be focusing on a simple application of how to begin with generative model. I'll be taking a well-known dataset known as the MNIST dataset. It's a dataset of handwritten digits, images of handwritten digits made by humans. It consists of around 70,000 images. And what I will be doing today is I will be taking this images and creating a generative model that will by itself generate new handwritten digits. You must be wondering, why do we need new images? So the reason is the 70,000 data set which was generated was by human, and it is very difficult for a human to label so many data sets, and it is a lot time consuming as well as resource consuming. So what if a model is able to generate similar images which is remarkably similar to the data set which was generated by human? So our generative model will be generating images, or we can say that the neural network will be able to we will be teaching how a neural network how to write, basically. So I will be showing the code on Python, and so if you want to install it, you can go to an Anaconda website, where you can get the Python packages, and according to your operating systems like Windows, Mac, or Linux, you can download the package and follow the instruction, and the Python will be set up. Along with that, you will be needing a Jupyter Notebook, which comes pre-installed in Anaconda itself. So once you have installed it, you can open your Anaconda terminal, and then there are few more libraries which you will be needing in order to be able to get the results for this generative model. One of the libraries is the TensorFlow, which is a deep learning library which will be helping in training both the generator and the discriminator neural network. The other library is the NumPy, which will be using for various matrix operations, and the matplotlib, which will be using to show the images and the graphs. So there is a basic command to install the libraries, such as pip. Okay. Pip install. If you want to install NumPy, you just type NumPy and okay. So connection reset. Okay. Yeah. So it's installing NumPy, and it takes a few time, and once it's installed, you can begin with your application. So okay. So first of all, the TensorFlow comes with MNIST dataset pre-installed. So you can just download the MNIST dataset from the TensorFlow libraries. And here's the code. Here you initialize all the libraries you need, and then you call in the MNIST data, which will download all the MNIST images, handwritten images. So it will download two folders. One will be the training folder, and another one will be the validation folder. In the training, there will be two sub folders. One is the image folder, and another is the label folder. So the image folder will have the various handwritten digit images, and the label folder will have all the labels, such as if the image is of 0, it will be of 0. The label will be 0. So okay, and so each of the pixels, each of the image pixels are of 28 cross 28, and you can see by just running this code. So this is an image of 6, or you can just see there are various. This is an image of 9. You can see there are a lot of different images of numbers written in different styles by human. So it is the training data itself is very very strong in itself. And so for the generative model to create this image, replicate this image, as I told you, that we need two components, the discriminator and the generator. So both are neural networks, and so in for neural networks, we use the TensorFlow libraries, which has inbuilt functions such as convolutional functions, layers to generate convolutional layers, as well as to have metrics for filtering out. So here is the code for the discriminator, how you create a discriminator. So in discriminator, we will be using two convolutional layer, along with that two fully connected layer that will be taking the input, the generator input, and trying to identify whether, giving a probability whether the image is real or fake. So the convolutional layer consists of filter weights, and here we can see that we are initializing a weight filter that we will be applying on the images to extract features from the image. So in the first convolutional layer, we define two weight filters, and then we define the convolutional layer on the image, and then we add the filter. We add the filter on the convolutional layer, and then do a ReLU. ReLU is we apply a ReLU function. ReLU function is basically a function that normalizes the outputs of the convolutional layer. So it is it is basically a function known as max of 0, x, where if the value is less than 0, it will output 0, and if the value is greater than 0, it will output whatever the value is. And then similarly, we implement the second convolution layer. It has again two new filter weights, and then we introduce the convolutional layer and apply the filter on the convolutional layer. And then again it's the same, we apply the ReLU. So this is basically it. This two convolutional layer is up to you. If you want to add more convolution layer, you can add. It will just increase the complexity, and these convolution layers are used to find more important features from your image. So as you go more deeper and deeper with your convolution layer, the more features you will get and the more accuracy you will obtain. So after this convolution layers, we implement a fully connected layer that will convert the features into a probability whether that image is real or fake. So at the end, we only get we only output one single value. You can see as it's one dimensional. We can see whether it's 1 or 0. Basically, it's real or fake. So that was about the function that shows a structure of how a discriminator is. And now the generator network. So in generator, basically it is a reverse of convolutional neural network, where typically in discriminator, where you try to given a high dimensional image and output a single dimensional output, where in generator you give a one dimensional noise and it tries to generate a particular dimension of image. So in this case, we will be inputting a one dimensional noise, and we will be generating 28 cross 28 pixel image. So the generator will be the model that will be generating images that will be similar to the data set. And for that we need it to generate a 28 cross 28 image, since data set is of the same dimensions. So in generator we use three convolutional layers where we again initializes filter, which will be filter weights which will be applied on the convolutional layer on the image, and extract important features from it, so that it can generate take that image, take that features and generate its own image. So the same method is used. Two filter weights are initialized, and then we normalize it, and then we use the ReLU function to further normalize it. And then similarly the second convolutional layer is used, and the third convolutional layer is used. Okay. Yeah. So in the final output, we will we as we go through the convolutional layers, we increase the dimensions of the images, so that at the end we get a 28 cross 28 dimension feature image. Sorry. So okay. So I will show you. Okay. Okay, so as I told you in the beginning, your both the generator and the discriminator are at a very basic level, and they don't have any idea about what a image looks like, or what a real or fake image digit look like. So when we run the basic generator and the discriminator, it will create an image which doesn't make any sense. It has noise, and basically it's untrained neural networks. Therefore, it will be generating random images with random noise. So now what we want to do is to actually train the generative model. So in order to generate the model, we will be initializing loss functions that will encourage the generator to create better images, and at the same time it will encourage the discriminator to distinguish the generated images from real images. So the training is in such a way that it trains both the generator and discriminator simultaneously, and in that process both of them gets better and better at their respective task. So here's a simple function that takes in the image, and it takes in the image and puts in the generator for the generator to generate the image. Then the output of the generator is then fed into the discriminator for the discriminator to find out whether it's a real number or a fake number, and we try to find the probability whether the image is image from the data set, or it's image from generator model. So for that we have two loss functions. As I said, one loss function is for the generator model to get better, for the generator model basically to understand the mistakes and train its weights, and so that it won't make its mistake again. And at the same time, the discriminator will be able to try to find minute details in the image, and identify mistakes which is possible by the generator. So we have set up the loss function for the discriminator and the generator. Okay, and then we use overall loss function to minimize the error from both the generator and the discriminator. So we use sigmoid cross entropy. It's an activation function that that helps to optimize, to reduce, or you can say minimize the loss function. And yeah, here I'm showing all the weights that we have used, such as in the discriminator and the generator. I have shown you that I have created the filter vectors, that's GW1, GW2, or the discriminator filter vectors, that's DW1 or DW2. These are the actual filter vectors which has a particular random weights, and how we can optimize this weights will determine how strong our model is. So we want to obtain a generalized weights for this filter vectors, and we do it by reducing the loss function. So what we do is basically, okay, yeah. So okay, we use a special type of optimizer called the Adam, which utilizes adaptive learning rates, and it basically has a learning rate. Here I have used a learning rate of 0.0003. You can play with different learning rates. It can be of 0.001 or 0.1, and you can try out yourself which gives the better results to you. And this Adam optimizer basically it basically tries to minimize the loss function, and by taking the loss from loss value from the generator as well as the loss value from the discriminator. So so once our optimizer is ready, we go through a method of iteration where we run the loss function and the optimizer function through various iterations. It can be like 1000 iterations, 2000 iterations. In this I had taken the iteration of 1 lakh iterations, and the only issue with this is it takes a lot of time, because it has a lot of processing power it needs. So for me, I used a GPU which took me around 3 to 4 hours to train the model to minimize the loss function, so that I can have the most optimal weights for my filter vectors. So if you are using a GPU, the process will be fast. It can be in 3 to 4 hours. But if you are using a CPU, it can take up to 10 times the GPU. So what I did is I already have already trained my model, and I saved that model so that I can use it for further use. But if you want, you can train your own model, so that since you changed your learning rate and you changed your different weights, you can use your own training model, and after it's done, it's better if you save it so that you don't have to retrain it again and again, and it will save a lot of time. So I already saved my model, and I just load my model, and I will show you some of the results which I got. One second. Okay. So these are some of the results which I got. As you can see, this image represents 3 or 4 or 0. So you can see how similar it is to the training data set. And this was this images which was generated by a model. So in a way, you can say that this model is able to write its own digits, and what we can do with this is we can add this images to our data set, and we don't need any human work to increase our training data set, and we can have our own model that can create the images. This model is just not we will be using for digit creation. We can use it for any kind of technique, such as for video creation or for text creation. So if you have a low training data set, and if you want to increase your training data size, you can generate your own generative model, and that will create more similar images of your data set, and which you can add to your data set, and it will increase your training data. So as you learned that generative models can be of various uses, and there are various applications, but the only issue is it takes a lot of time to process it, and it is very difficult to get that amount of resources. But if you have access, you can definitely have your own generative model, and it is pretty easy to use to create your own generative model, since we have all the predefined libraries. We just have to install it and just use it. So generative models is a very new features in the field of artificial intelligence, and a lot of people are working on it, and I hope I gave you a basic understanding about the generative model and how to start working with it. And I will be making this code open source, so that you can refer to it and use it. And if you have any other doubts or anything, you can just comment or just message me. I will be available 24 hours. And yeah, and if you want to look into my work, you can just visit archie.ai and look at our website.